So let's say you need to build a truly massive AI supercomputer. We're not talking about a couple of servers. We're talking about the kind of systems that are going to define the next decade of technology. The big question is, where do you even start? Right now, there's this fascinating battle of philosophies raging over the best way to build these giants. Okay, let's dive right in. All right, so picture this. You've been tasked with building an AI system with, say, 32 of these incredibly powerful accelerators. This is so much more than just buying a bunch of chips and plugging them in. You're making a fundamental choice about your design philosophy, a choice that's going to affect everything from raw performance and cost to which company you're basically married to for years to come. And look, any conversation about AI hardware, you just have to start with the undisputed king of the hill, NVIDIA. Their whole strategy is what we call the monolithic or scale-up approach. The core idea behind NVIDIA's world is frankly brilliant. They don't just connect a bunch of GPUs together. They try to fuse them into what feels like one single massive logical unit, a supernode. And how do they do it? With their own high-speed proprietary links that act like a private superhighway just for the GPUs, letting them all talk to each other almost instantly. The easiest way to think about it is like this. NVIDIA uses its custom NVLink and NVIDIA switch tech to make dozens of individual GPUs act as if they were one single gigantic GPU. This is huge for developers because it makes programming so much simpler. The system just handles all that complicated communication in the background, giving you this one unified block of memory and compute to work with. But here's the thing. NVIDIA's dominance comes from way more than just the hardware. They've built this entire ecosystem around it. Their CUDA software platform, it's the industry standard, period. All the big AI frameworks you've heard of, PyTorch, TensorFlow, they're all optimized for it right out of the box. It's seamless, it's powerful, it's a turnkey solution. So what's the catch? Well, it's the classic walled garden. You get absolutely incredible performance, but you are locked into their hardware, their software, and yep, their prices. But that very lock-in, that's the crack in the armor. And it's creating a massive opportunity for challengers who are coming at this with a totally different playbook. It's all about scaling out, not up. So the scale-out philosophy is a fundamentally different game. Instead of building one giant hyper-integrated machine, the idea is to connect lots of smaller, standard servers together. The magic ingredient here is using open commodity networking, the same kind of Ethernet or InfiniBand that already powers pretty much every data center on the planet. It's modular, it's flexible, and it helps you avoid that proprietary lock-in. Now, inside this scale-out world, you've got a couple of different flavors. AMD, for instance, takes this kind of hybrid or federated approach. They use their own special Infinity fabric to connect GPUs super tightly inside a single server, but then they use standard networking to link all those servers together. Intel, on the other hand, with their Gaudi accelerators, they're going all in. They're betting the farm on standard Ethernet for everything, even for the communication between chips inside the very same box. So this is the whole bet right here. Intel is making this massive wager that standard off-the-shelf Ethernet is now fast enough, with low enough latency, to handle the absolutely insane communication demands of large-scale AI. And if they're right, well, this could completely change the economics of building these AI supercomputers. Okay, so that's the theory. Let's make this way less abstract. What does it actually look like to build a system based on this open scale-out idea? All right, check this out. Here is a basic shopping list for a 32 accelerator system using Intel's Gaudi 3. You can see the modularity right away. We're just taking 4 standard servers from a company like Dell, each with 8 accelerators. Then we connect them with standard off-the-shelf high-speed Ethernet switches. See? There's nothing super exotic here. It's all built from components you'd find in a modern data center. And now for the punchline. This is where it gets really interesting. When you add it all up, the cost difference is just staggering. A 32 accelerator system built on this open Ethernet native approach is estimated to run you about $1.34 million. An equivalent system built with NVIDIA's H100s, we're talking almost 3 times as much, at nearly $3.9 million. That's not just a little cheaper, that is a game-changing difference. And you gotta remember, that hardware price tag is just the start. When you scale this up for huge enterprise-level projects, the numbers just get astronomical. A system like this could easily blow past tens of millions of dollars once you factor in things like global shipping, import taxes, and all the services to get it working. These are massive financial decisions where every single percentage point of savings really, really matters. So this brings us all the way back to that central question. The decision you have to make isn't really about which chip has the most teraflops on a spec sheet. It's about which architectural philosophy you want to buy into for the long haul. So let's just lay it all out side by side. With NVIDIA, you get that monolithic one giant GPU approach. Its strength is guaranteed turnkey performance backed by the best software in the business. The trade-off? High cost and vendor lock-in. With AMD's federated model, you get these really dense building blocks with a ton of memory, a nice balance. And with Intel's Ethernet native play, you get maximum flexibility and major cost savings, but you're betting that standard networking and the software can deliver the performance you absolutely need. At the end of the day, the entire battleground for AI infrastructure has shifted. The choice isn't just about grabbing the fastest chip anymore. It's about picking the right ecosystem for you. It's a strategic decision between a closed, integrated system that, well, it just works, versus an open, modular one that offers you freedom and a whole lot more value. So I'll leave you with this final thought. As the demand for AI computation just continues to explode, which of these philosophies do you think is going to win out in the long run? Is that guaranteed turnkey performance of the walled garden worth the premium price tag? Or will the flexibility and the incredible cost advantages of the open ecosystem ultimately win the day and democratize how we all build these AI giants? The answer is going to shape the entire future of this industry.